Hi, physics. This is Mr. Janowski. This is the first part of the Chapter 5 slides. So let's think back to what we've learned about vectors. How are vectors different than scalars? Well, scalars only have magnitude, which is size, whereas vectors have magnitude and direction. So it's the direction that vectors have that scalars don't have. So what type of vectors are easiest to add? Parallel vectors or anti-parallel vectors, meaning vectors that are in the exact same direction or the exact opposite direction. These are very easy to add. The question 3, what type of vectors are slightly harder to add? They're a little bit harder to add when your vectors are at right angles. So you have to use the Pythagorean theorem to do those. So that makes it a little bit harder. And then, finally, what type of vectors are hardest to add? Vectors at arbitrary angles. So they're not in the same direction or opposite direction. Excuse me. Your vectors are not at right angles to each other. They're just at some other angle. Those are the hardest to add. And then what are the two ways we've learned so far to add vectors? That would be the parallelogram way and the tip-to-tail way. So this is the start of Chapter 5, Projectile Motion, 2D Kinematics. Last chapter, Chapter 4, was Linear Motion, 1D Kinematics. So in the last chapter, things were either going up and down, or they were going left and right, but they weren't doing both at the same time. In this chapter, they will do both at the same time. So it makes things a little bit more difficult. So Clarence Over, Roger Murdoch, and Victor Basta, these are all characters in the movie Airplane. So the captain, this is Clarence Over, this is Roger Murdoch, this is Victor Basta. Doesn't matter, but I love the movie Airplane. Best comedy of all time, funniest movie ever. So again, with vectors, if they're parallel, you can add them very easily. If they're at right angles, you can add them. It's a little bit harder. You've got to use Pythagoras. And if they're at arbitrary angles, then these are the hardest to add. So in Physics 1, we only ever do this graphically. We'll lay the vectors down and attach them with parallelogram rule or do tip-to-tail or do whatever. And we'll just get a sense of which way they're going. But you don't have to do it mathematically, and you don't have to come up with an exact number in this case. In Physics 2, currently that's what they're doing, is they're doing the mathematical way of adding vectors like this. So again, we have the parallelogram rule. So add the red and the blue. That would give you this black vector here. It's called the resultant. The sum of vectors is the resultant vector. Again, the parallelogram rule. And finally, the tip-to-tail way. So this is the best way to add more than two vectors at once. You can just add as many as you want. Just keep doing them tip-to-tail. And then I asked you, what kind of plane is this? This is the P-51 Mustang. This is my favorite plane from the World War II era. Very important plane historically. I went into it in class in great detail, but I'm not going to go into it now. Point is, a Mustang is a type of plane. It's also a type of muscle car that Ford makes. But before that, it was a type of plane made by North American Aviation, I believe, was who made it. Doesn't matter. So the question is, we've got our Mustang, our plane. It's going due north at 200 kilometers per hour. And then all of a sudden it gets a 50 kilometer per hour tailwind. So now the wind is blowing behind the plane and pushing it forward faster. So how fast will the plane end up going and in what direction? Well, these are parallel vectors, so you just add them. 200 plus 50 gives you 250 kilometers per hour, and we're going due north still. Next situation. Plane's going 200 kilometers per hour north. This time it gets a 50 kilometer per hour headwind blowing south. So this is a wind blowing into the face of the plane that's going to slow it down. So how fast will the plane be going and in what direction? Well, these are just anti-parallel vectors. So just subtract the small one from the big one. You end up with 150 kilometers per hour. And we're still going due north because everything is still happening in a straight line. And then finally, for the hard one, you've got the plane going north at 200 kilometers per hour. This time the wind is blowing 50 kilometers per hour due east. How fast will the plane be flying relative to the ground with the wind? And in what direction? This is harder. To do this, we need to use Pythagoras to get the speed of the plane, and we need to use SOHCAHTOA, trigonometry, to get the angle there. So that'll be a little bit trickier. So this green character right here, that is the Greek letter theta. In math and science, we often use theta to represent angles. So that is theta. So first, the Pythagoras part. I'm sure you've all had lots of experience with Pythagoras. This is a squared plus b squared equals c squared. So this is a way to figure out the lengths of sides of right triangles. And as long as you make the hypotenuse b side c, right, everything will come out fine. You can switch a and b around. It doesn't matter which one of these is a and which one is b, but c has to be the longest side. It has to be the hypotenuse. Anyhow, you do it with these numbers, and it turns out that c is 206.2 kilometers per hour. So that's how fast the plane is going. Now to get the direction, we've got to use trig. So people taking Physics 1 will have had different amounts of math at this point in their life. Some of you know trig already. Some of you don't know trig at all. Don't worry if you're in that latter group, because I will teach you just the small amount of trig that we need to do for physics, and it will just make you better at trig when you have to do it in math class. So what is trigonometry about? It's about figuring out the lengths of sides and sometimes the angles when you're dealing with right triangles. So this is trigonometry in a nutshell, just the basics of trig. So a lot of time you will have the length of one side and you will have one of the angles other than the right angle. We're assuming that there's a right angle, but you know one of the other angles. And you want to figure out the length of a second side. So that's one way you can use trig. In other situations, you will have the lengths of two of the sides, and you have to know what sides they are. Is one the hypotenuse? Is one opposite or adjacent? And you're trying to figure out one of the angles. So the way this works, the way so much of the math that you will do in physics and so much of the math that you will do period works, is when you're using a trig identity. So sine theta equals O over H, that's a trig identity. When you're using one of these things, all of those trig identities, trig formulas, trig equations, all contain three things. When you're doing one of these problems, you will know two of the things, and you need to solve for the third thing. So there's three things total. You know two, get the third thing. In a kinematics problem, there might be four different things in the equation. You know three of them, get the fourth thing. Things like that. That's how it works. So, yeah. So the three sides of a triangle, more on this to come, but there'll be the other three sides of a right triangle, I should say, will be the hypotenuse, the opposite, and the adjacent. I'll show you how to figure out the opposite and the adjacent. So those are just lengths of sides. So those are conceptually not too difficult. The thing that scares people when they've never seen trig before is, what does sine theta? What does that actually mean? Cosine theta, tangent theta. They're ratios, they're things like that. But as far as we're concerned, these are just numbers. These are numbers that your calculator knows. If you ask your calculator, what is the sine of 15 degrees, your calculator will tell you the number. So it's just a pure number is all you need to know. And then sometimes, again, in this first situation, you will know one side and the angle, and you're trying to solve for a different side. The other thing that can happen is you will know two of the sides, and you're trying to figure out the angle. So this is the time for inverse trig. And there's ways to do that with the inverse trig. I've already made a video that shows you how to do different trig problems, and that video should probably be more helpful than this particular video. I'm explaining the stuff in the slides, but it's all very abstract at this point. So watch that video too if you're having trouble with this. So how does trig work? So anytime you have a right triangle, there are four pieces of information that you're going to care about. The lengths of the three sides, the hypotenuse, the opposite and the adjacent side, and the angle theta. So if we're looking at this triangle, any right triangle, the longest side will be the hypotenuse. So here is our right angle here. The hypotenuse is across from that. It is opposite the right angle. That's the hypotenuse. If you're doing a trig problem, you will be dealing with one of the other two angles. So in this case, either the bottom left one or the top right one. Well, we're dealing with the bottom left one. So the purple side is the hypotenuse. How do we figure out which one is the opposite and the adjacent? Well, the opposite side is the side that is opposite on this triangle from the angle you're dealing with. So here we are starting at this angle. Just go opposite. So go across the triangle, and that gets you to the opposite side. Which side is the adjacent side? Well, adjacent means next to. So if we're dealing with this angle here, there are really two sides that are next to this angle. One of them is the hypotenuse, so we just call that the hypotenuse. The other one is the one we call the adjacent. So if we're dealing with this angle here, the blue side is the adjacent one, the red side is the opposite one. If we were doing a different, we were doing this problem differently and we had this top right angle up here, it would flip. In that case, the vertical side here, that would be the adjacent, and this side here, the horizontal side, would be the opposite. So which one's opposite, which one's adjacent? Well, that depends on which of the other angles you're using. So SOHCAHTOA. So don't think of SOHCAHTOA as one big word. Think of it as three little words. The first word is so. And the way this little mnemonic device works is the first of the three letters tells you which trig function you're going to use. So if we're looking at so, the S tells you that you're going to use sine of theta. And then what happens with the other letters? The middle letter goes on top, and it gets divided by the end letter. So means sine theta, and then you have opposite divided by hypotenuse. Ka, C tells you cosine theta, and then what comes next? That is equal to the middle letter, A for adjacent, divided by the third letter, H for hypotenuse. And then TOA. Well, the T tells you tangent of theta, the O means opposite, the A means adjacent, so opposite divided by adjacent. So that's what SOHCAHTOA means. And I will kind of preview this idea that's going to become important later in this chapter. So far, we have talked about adding vectors together. So we might start with the blue one plus the red one, and that will end up giving us the purple one. What we're going to do mostly in this chapter is start with the purple one and the angle, and we're trying to figure out, well, what two other vectors make up this vector? So what is the blue one? What is the red one? So if you're adding vectors together, they sum up and give you the resultant. If you're starting with a vector already and you're breaking it up into pieces, which is what we're going to do most of this chapter, the pieces you break it up into are called components. So we're trying to find two components to this purple vector that meet at a right angle. And the right angle thing is very important. In math, when things are perpendicular, when they're meeting at right angles, they are what is called independent of each other, which means basically they stay out of each other's way. So we would want to turn this purple guy into a horizontal component called v sub x plus a vertical component called v sub y. So we're doing this. Remember, a while ago, we started talking about this Mustang and trying to figure out this angle. So Pythagoras gave us the purple side, 206.2 kilometers per hour. So at this point, we know all three sides of this triangle, and we're trying to figure out the angle. So to do that, we just need to pick one of the trig functions and any of the two sides that go with it. And we know all three, so we could use any of the trig functions. I did this using tangent. So tangent of an angle is the opposite over the adjacent. So in this case, what does that mean? Tangent of this green angle is equal to opposite over adjacent. Well, opposite is 50, adjacent is 200. So tangent of theta is equal to 0.25. That's 50 divided by 200. This is a case where you need to use inverse trig. Trig will get you a second side. If you already know two sides and you want the angle, you use inverse trig. So if tangent of theta is equal to 0.25, you want to ask your calculator, well, what's the inverse tangent of 0.25? And your calculator will tell you the angle theta. So you do that, you get 14 degrees. So what does this mean? This means that our Mustang with this due east wind ends up going 206.2 kilometers per hour at an angle of 14 degrees east of north. So start off going due north and then go 14 degrees towards the east. And that is how fast your Mustang goes. And then finally, we didn't watch this one in class, but I'll put a link to this in the description of this video. Is trigonometry about triangles or circles? The answer is yes. It's about both. The way I taught you this is using triangles. Well, it's kind of in the name. Trigonometry. Metry means measure. We're measuring triangles. That's usually how people think of trigonometry the first time you learn it. Well, this guy here, this mathematician, is going to tell you that trigonometry can also be viewed as being something about circles. And if you happen to like math and the beauty of math and the mysticism of math, you might like this video. I like this video very much. It's neat stuff. So I'll put a link to this video in the description to my own video. And I'll put a link to the airplane video too, because that's important. You need to watch that. And also, I'll put a link to the homework problems I just did. So hopefully you guys found this helpful.